Hello everyone, my name is Zhongzhi, advised by Professor Yingyan Celine at ESC Lab in Georgia Tech. Today I'm going to introduce our work, Master-ASR, Achieving Multilingual Scalability and Low-resource Adaptation in ASR with Modular Learning. This work is collaborated with Zhang, Kaizhi Qian from IBM and Cheng, Yonggan, Yongan from ESC Lab in Georgia Tech. In recent days, ASR system is of an increasing demand as it's one of the key interfaces between human and computer. However, the road towards real-world ASR applications is still non-trivial. Specifically, the challenges comes from two aspects: multilingual scalability and low-resource adaptation ability. Existing methods towards multilingual scalability either tune an adapter for each language, which leads to non-trivial training overhead, or leverage a larger model, which can lead to excessive inference and storage overhead. Despite the promising performance, we wonder how to avoid excessive overhead in training, inference, and storage simultaneously. On the other hand, existing methods for low-resource adaptation either tune an adapter on top of the model, which can lead to overfitting issue, or utilize data from other modalities such as unpaired text, which can lead to catastrophic forgetting issue. Despite the progress in low-resource ASR, we wonder how to push low-resource performance further by avoiding overfitting and catastrophic forgetting issues. We identify an opportunity on solving the above challenges that different languages share similarities at various levels. For example, Hebrew and Arabic share a high syntactic similarity, while Spanish and Italian share a high phonetic similarity. Thus, we hypothesize that it is possible to adaptively share certain parts of an ASR model across different languages. And to this end, we propose our Master-ASR framework, the key idea of which is to adaptively share submodules across different languages. For example, in the figure below, Chinese and English shares the green submodule. And our Master-ASR integrates an architectural contribution that we propose the Artisan layer, which replaces the original projection and the QKV layer in transform block with Artisan projection and QKV. The design of Artisan layer enforces adaptive share of submodules across different languages. We also propose a two-stage training pipeline, integrates multilingual training to avoid excessive training overhead, and low-resource tuning to elevate overfitting and catastrophic forgetting. We first introduce our proposed Artisan layer, which aims to avoid excessive overhead in inference and storage of multilingual ASR. The key insight of Artisan layer is that we can hierarchically control submodules to generate a language-specific binary mask. To achieve this, we use a mapping matrix to control the summation of specialist modules and generate a binary mask by top case selection and apply this mask on top of the layer weight. Then, in our training stage 1 multilingual training, we aim to avoid excessive overhead in training by simultaneously support multilingual ASR by learning a set of generalizable but diverse specialist scores. We achieve this by avoiding the collapse of mapping matrix by separate learning rate and enforce the specialist scores convergence by iteratively update specialist scores and model weight. And in stage 2 low-resource tuning, we aim to avoid overfitting and catastrophic forgetting issue. To this end, we propose to learn to support the new low-resource language by combining the learned specialist scores. We achieve this by only tune an additional row in mapping matrix with all the other parameters in the model freezed. We evaluate our proposed method on a multilingual dataset with 51 languages and a low-resource dataset consists of 10 minutes of training data for each languages. We use a pre-trained XLSR53 as our backbone model and use the character error rate as our evaluation metric. We observe that Master-ASR achieves as high as 2.41 lower CER with 30% less inference overhead over multilingual ASR baselines and nearly 50 times fewer trainable parameters with a comparable CER over SOTA solutions in low-resource tuning. Please visit our poster for more details. Thank you for your time. Here's my presentation of Master-ASR. Please feel free to scan this QR code for our project page for more information. Thank you.